Hello everyone, and we have a bias design problem here. The question asks us to design the circuit such that this transistor operates in the saturation region. Source to drain voltage is biased 1 volt from the edge of the saturation. And we would like to have a drain current of 1 milliamp in our circuit and the drain voltage or the node voltage at the drain to be equal to 3 volts. We want to use a 10 microamp current in the voltage divider circuit. The threshold voltage for the MOSFET for this PMOS transistor is 1 volt, or is equal to negative 1 volt. The threshold voltage for a PMOS transistor has a negative value, and Kp or transconductance of the large signal transconductance of this MOSFET is equal to 0.5 milliamp per volt square. It asks us to neglect the channel length modulation effect or to equate lambda with 0. Okay, let's get it started. So let me see the unknowns for my problem. Rs is unknown, Rd, the drain resistor value, is unknown, R1 and R2 are also unknown. And what do I have for, and the known parameters are the drain current, which is 1 milliamp, so the current that flows in this direction ID is 1 milliamp. Also this is the same ID, 1 milliamp. And let me label them so it's clear. So this is source, this is drain, and this is gate of my transistor. This is plus minus VGS. Also I know that the gate current is 0 in MOSFET transistors, so this I sub G is equal to 0. What else do I know? The drain voltage is at 3 volt, so this VD is equal to 3 volts. The drain is at 3 volts. So I also have this 10 microamp current in the voltage divider circuit. So 10 microamp flows in this direction. I have 10 microamp current here, and the same current goes through this R2 because IG is equal to 0. So that is another information that I have. And just by looking at it, I would like to make a plan for solving this problem. I can use the drain voltage of 3 volts and a known drain current to calculate RD, because RD is VD over, so let me see, take some notes. I can do this one, ID over RD, and then I can get the value of a drain resistor. For the voltage divider network, that is this is my voltage divider network, so this is it. From here I have the current that flows through R1 and R2, so I can write this one, 10 volts equal to 10 microamp for R1 plus R2. So that's one equation that I have. I can use it to calculate R1 and R2. Other than that, what else? So I have this information. VSD is biased 1 volt from the edge of the saturation. I want to use the transistor in the saturation region. So PMOS in the saturation means so that means VSD should be greater than or equal to V over drive. Now it says that VSD is biased 1 volt from the edge of the saturation. So edge of the saturation is when I have VSD equal to V over drive. Now in this problem I have VSD to be greater than 1 volt above the V over drive. Obviously this is 1 volt above the V over drive because I want VSD to be always greater than or equal to V over drive. So 1 volt from the edge of the saturation means V over drive plus 1 volt. So I have that information. Let me take a look at go back to my plan. So if I have the drain voltage here, which is at 3 volts. So I don't know the value of V over drive. I don't know the source voltage. So but I have ID. So if I have ID and I know the transistor operates in saturation region, I have one piece of the puzzle. ID is equal to 1 over 2 Kp V overdrive to the power of 2. This is the current equation for the MOSFET when it operates in the saturation region, and lambda is equal to 0. So in this equation, the value of ID is known, the value of V overdrive is not known. So I can calculate V overdrive. If I do that, I'm gonna have so if I calculate this V overdrive from this equation, I have this one, and if I have V overdrive there, I have VSD here, and if I have VSD, because I already have V voltage of the drain, I'm gonna get VS voltage of the source. Now that means I have the node voltage at this node, source node, and if I have Vs, I can get the value of Rs, because Rs is equal to 10 minus Vs divided by ID. Okay, so if I have, now that I have source node voltage at the source, or Vs, and I have V overdrive, I can get the value of gate voltage from, let me rewrite this one. I have Vs, I have V overdrive. From there I can get the value of Vg, and if I have the gate voltage, because it is equal to R2 divided by R1 plus R2 multiplied by 10 volts, then I'm going to have an equation for R1 and R2. I have another equation for R1 and R2 in here. From there I can get the value of R1 and R2. So with this plan, I can get the values of Rs, Rd, R1 and R2, which are all the unknowns that I have for this design problem. Let's go ahead and write all of these equations and calculate the unknown values. So the most obvious one is Rd, which is equal to Vd divided by Id. That's equal to 3 volts divided by 1 milliamp. That's going to give me 3 kilo ohm for drain volt resistor. So I'm going to use the drain equation, or ID, to find the V overdrive value. So ID is equal to 1 over 2 Kp multiplied by V overdrive to the power of 2. Lambda is equal to 0. There I have 1 milliamp equals to 1 over 2 multiplied by 1. Kp is 0.5 multiplied by 0.5 milliamp per volt squared multiplied by V overdrive to the power of 2. From there, V overdrive can be calculated to be equal to 2 volts. Now VSD is equal to V overdrive plus 1. The problem says VSD is biased 1 volt from the edge of the saturation. From there, VSD is going to be equal to 3 volts. Because VSD is equal to V source minus V drain, then I have this one equal to 3 volts. So Vs minus 3 volts for drain voltage is equal to 3 volts. From there, source voltage is equal to 6 volts. I can get the source resistor value. So Rs is equal to 10 volts, that VDD, minus Vs, which is 6 volt, divided by ID, which is 1 milliamp. So it's going to be equal to 4 kilo ohm. Now I have the values for Rs and Rd. So from right now, so far I have Rd is equal to 3 kilo ohm, and I have Rs is equal to 4 kilo ohm. So this is one of my unknowns, and this is the second one. On, I have V overdrive and I have Vs. I'm gonna get the value of gate voltage. This is plus minus VSG. So this is my source node and this is my gate node, and I'm going to use that information to calculate R1 and R2. So V overdrive was equal to 2 volts, and I know that V overdrive, based on definition, it's equal to VSG minus VT. And in this equation, I need to use VT with its absolute value. So now Vs is equal to, I calculated Vs to be equal to 6 volt. So VSG, from this one, VSG is equal to 2 plus 1, which is going to be equal to 3 volts. And I have VSG to be equal to Vs minus Vg is equal to 3 volt. From there, 6 minus Vg equals to 3. And from there, gate voltage is equal to 3 volts. So that is my gate voltage. And because I have a voltage divider network in here, I can write Vg is equal to R2 divided by R1 plus R2 multiplied by 10 volts, which is equal to 3. From there, I have R2 is equal to 3 over 10 multiplied by R1 plus R2. And other piece of the information that can tell me that can help me to calculate the value of R1 and R2 is the current that flows through R1 and R2, that is 10 microamp current. So I can write a KVL from 10 volt to the ground, and that's going to tell me 10 volts equals to 10 microamp multiplied by R1 plus R2. Because Ig is equal to 0, there is no current flowing in here. In here, Ig is equal to 0. Okay, so from there, the same 10 microamp flows on R2 and through R2 and through R1. Okay, so I have another information, another equation. So two equations with two unknowns, I can solve them to get the value of R1 and R2. The first one, I have 3 times R1 plus 3 times R2 equals to 10 times R2. From there, I have 3 times R1 minus 7 times R2 is equal to 0. From the other one, R1 plus R2 is equal to 1. I know that the resistor values that I'm going to get from these two equations have the unit of mega ohm, because the current that was flowing through R1 and R2 was in the range of microamp, had the unit of microamp. Okay, so if I solve this to these two equations, I'm going to get R1 is equal to 0.7 mega ohm and R2 to be equal to 0.3 mega ohm. So I found all of the unknowns in my circuit to finalize the design. So I have all the unknowns and the design is complete.